This is a summary of Algebra 1 forms of the line for use in a geometry classroom. We'll talk about some of the forms of the lines from algebra. And so we'll start with slope. Slope is generally designated as m in equations. It's the change in y over the change in x. The delta or triangle meaning change in y over change in x. It's calculated by using the coordinates, 2 points on a line. The y coordinates are subtracted, the x coordinates are subtracted to find the difference, and they're divided to make a ratio. So we'll have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The y value from 2 minus the y value of 1. A positive slope means going uphill from left to right, like this line, or even a more steeper positive slope, a less steep or smaller positive slope, and a negative slope. A steep negative slope, which would have a higher number, bigger than 1. A more shallow negative slope, which would have a lower absolute value number, less than 1. Zero slope is flat. Your skateboard goes nowhere. Undefined is the vertical. It's undefined because when we go to calculate it, you would say we would have a point here and a point here to use to subtract. The y values are different, but the x values are the same. So when you subtract, you get 0. Thus, you would try to divide by 0, which we cannot do. It is undefined. Here's a review of the forms of the line. Probably should write these down in your cipher to make sure you know what they are. Let's make a note from Algebra 1. In Algebra 1, if you would have had 2 equations and solved it as a system, or by graphing it, algebraically or by graphing, you would find out that it's the same point. Many times in Algebra 1, you would have said that there were infinitely many solutions, and that's true. And from the geometric perspective, what we're going to say, it is the same line, as opposed to that they're different equations. These 2 equations were the same, always were the same. This one is just times 3. They are equivalent equations. So when you solve a system and you get infinitely many numbers of solutions, the original equations were the same equation. One was just equivalent. Slope of parallel lines. Again, a review from Algebra 1. Slope of parallel lines. This is our postulate. Lines are parallel if and only if they have the same slope. Remember, if and only if from our logic unit. IFF. It's a word. It's a word in the Scrabble dictionary. You can use it in Scrabble, but it's not a word that has a pronunciation so far as I know, or as dictionary.com knows. So we have two lines. If the slopes are the same, then they are parallel. Another postulate, the slope of perpendicular lines. Lines are perpendicular if and only if the slopes are the negative reciprocals. Another way to say negative reciprocals is that if you multiply the 2 slopes, you will get -1. Here we have an example of it. How would we write equations? Different ways to do it. For example, with this one way might be to do it. Since you have the y-intercept, the slope-intercept form might be a convenient way to use because you know the intercept at the y-axis is -4. You can count pretty easily and get the slope and plug that in, substitute it into the slope-intercept form. Just some suggestions here. Sometimes one way is easier than the other. I would suggest that you not always use the same form. Many times in geometry, the point-slope form is actually the easier one to do, or the easiest one to do. It's usually pretty cumbersome to try to start with the standard form, so most folks want to start with either point-slope form or slope-intercept form. You'd choose point-slope form if you had the point and a slope, the slope and a point. You'd choose slope-intercept if you had or could get easily the slope by counting and the intercept. Here you've got the intercept, you can count the slope, that's probably the easiest. Here you don't have either one, the intercept or the slope. Well, you can count the slope and you can back it off and get the intercept if you want. Or it's probably easier to use the point-slope form since you know 2 points exactly. So when there are 2 points, it's probably easier to use the point-slope form. And you're not allowed to guess. Oh, that looks like it's about. No, you're not allowed to do that. If you don't have the intercept, you'll have to use another way if the intercept is not given to you. Or if you don't have a means to officially count the slope, you'll have to find another way to do that. For example, if you're given the values of the points, you would need to use the slope formula, which we just had. Here's some examples. Write an equation of a line that passes through the point and is parallel to the line. Let's say, for example, here, it's going to be through that point and parallel to that line. First, you'll have to find the slope. Recall that you can't easily tell the slope from standard form. What you'll need to do probably is to change it to slope-intercept form. That's probably the easiest way, because then whatever the coefficient of the x term is the slope. Pretty easy way to find the slope. So if you were to change this by isolating y to slope-intercept form, then the coefficient of x, once it's changed, would be the slope, and then you could do it through this point with the point-slope formula. You'll do similar types of things with perpendicular lines. And don't forget these pesky little lines that don't look like lines because there's not enough letters there. Y equals -3 is the equation of a line. It's one that where y is always -3. It is a zero slope line. X equals 20 is the same deal, but it's an undefined slope line. So just remember that those are lines. So for the one that I pointed out here, it would work out like this. To find the slope by isolating y, putting it into slope-intercept form, we find that the slope is -5/2. Plug it into the point-slope form. Notice it doesn't say any particular form that it has to be in. A lot of people like slope-intercept better, but point-slope is perfectly acceptable, as is standard form. How are you going to identify a parallel line? Well, here's a few of them that you can look at. So parallel lines would have the same slope, so you need to find the slope of each one of them to see if they are, as the manner that we just did. One way to do it is to change them all into slope-intercept form. Then the slope will be the coefficient of x. You can use the intercepts to form it by being 2 points, and the slope is easy to count. Slope is really easy to count when you have the 2 intercepts. Okay, well, here endeth the lesson.